Hey everybody, I want to do a quick little video about how to do a law of science question. And I'm going to kind of go back to the beginning of this. So if you needed a little bit of a review of why things go the way they go, then hopefully that will help with this video. All right, so some of the things that you're supposed to learn or you need to learn when you're talking about the law of science is just how to use it to solve oblique triangles. Oblique meaning a non-right triangle. And you can do that with a triangle where you are given two angles on a side that's not included, an angle, an included side, and another angle, or even side-side angle. And we have actually already used it for some real life application stuff. So just to introduce some things to you, oblique triangles are triangles that have no right angles. And as standard notations, we label the angles with A, B, and C, and their opposite sides are labeled A, B, and C, also using lowercase letters. And we have been doing that for a while now. That's just a review of that. To solve an oblique triangle, you need to have at least one side and at least an angle, or better even yet, two sides and two angles, or one angle and one side, some various combination of pieces. And in green here, those are the configurations of triangle angles and sides that you can have that will allow you to use the law of sines. Number 3 and 4, those are law of cosines problems, but we will not address that in this video. So the first two cases, like I just said, are law of sines questions. And then the side, side, and side angle cases are law of cosines. Here's your law of sines in the highlighted area there, and we've been doing that as well. So that should look familiar. And then, one thing we didn't really talk about a whole lot, but we did mention it briefly, is that you can write these in the reciprocal form, and they are the same. I typically do not use this form. This is the form that the person who made this PowerPoint prefers, but I like doing the sides on the tops of my ratios. So you have to have it consistent though. Either like all three sides are at the top or all three sides are at the bottom of your ratios. Can't kind of pick which way you want it on one and change it on the other. All right. So if you are given a triangle like is in figure 6.3 here, you're given angle C, angle B, and side B, and we're trying to solve the triangle, find the remaining angle and sides. You should first find this missing angle because all three add to be 180. It really is a matter of figuring out how many degrees these are total, subtracting that from 180. It ends up being 49. So we found angle A, and now we've got to find side A and side C. That involves a little bit more work. If you plug in all of the information you have gathered with this triangle, you will see that you are missing side A and side C. Now, we can only use two of these ratios at a time. You want to use the ratio you do know for sure that has both the side and the angle opposite that. That would be the middle ratio in this case. And you want to set it equal to one of these and then set it equal to the other to find A and C. So I would use the first two ratios and solve for A. And here's how I did that. So cross multiplying A times sine 28.7 is equal to 27.4 times the sine of 49. And that would give you the following fraction after you divided both sides with a sine of 28.7. After that, you just put this in the calculator, and that would give you 43.1. Similarly, you can use the last two ratios we wrote to solve for side C. So again, cross multiply, and I sort of switched the order of my fractions here, but I just did that to make it easier on me when I was typing these slides. You don't have to write them in that order, but anyway, I just wanted to mention that. So if you cross multiply, C times the sine of 28.7 is equal to 27.4 times the sine of 102.3. To isolate C, we need to divide both sides by the sine of 28.7. And doing that, we get this fraction here. It looks a lot like the one we had, but we're using a different angle to find a different side. That side length will be 55.7. So there you have it. There's an example problem of how to do a law of sines question when it is angle, angle, side, angle, side, angle, one of the two. The next thing we will learn is the ambiguous case, and that is side-side angle, and I will share that in another video.